Hello students, welcome to samclasses. The determinant section was long pending and due. Let's start it, let's finish it off. Now in the determinant section, first we need to know what is a determinant. So basically, determinant, what do you understand, right? Let's see. So it is a number or a value which determines the uniqueness of a solution associated with a square matrix. Okay. Now what do you understand by that? Okay, it sounds pretty complex, correct? So let's go to the basics. Okay, now we have an equation, very simple one, a1x plus b1y is equal to c1. We used to solve in class 9th. a2x plus b2y is equal to c2. So we have this equation as 1 you say it, this as 2 you say it. Okay, so these two equations are there. If we want to find the value of this, if we solve it out, or if you remember that we used to do in 9th whether the solution is unique or not, these two represents what? Two lines, line L1 and line L2. Now they'll have a unique solution, okay, if, what is the condition? If they're intersecting, correct, unique solution. So then what has to happen? A1 by A2 should not be equal to what? B1 by B2. And the value, a unique value was represented. What is that value? A2, A1 B2 minus A2 B1, A1 B2 minus A2 B1, and this value is nothing but the determinant of a square matrix. So for a square matrix, the determinant basically is a value associated with each square matrix. Okay, nothing more than that. Again, let's recap. It might sound a bit complex. Again, let's make it more simple. For any square matrix, okay, A1, B1, let's say for an example, A2, B2. So the value A1, B2 minus A2, B1 is known as the determinant of the matrix. Okay, students. So very simple. Don't go too complex. Just this value associated with this square matrix is known as the determinant. Okay. Now let's see the next part. For every square matrix, okay, A equal to A of ij, okay, what we have of order n, a number, it can be a real or a complex value. So whenever you get a determinant value, don't always think that it has to be a real one. It can be real or a complex. Is associated with a square matrix, okay. So a matrix A is equal to, we have given A, B, C and D, okay. So the determinant of A will be what? We denote it by this, what do you say, two straight lines A, B, C and D, and we write determinant of A. A lot of people, a lot of students, what they do, they start pronouncing as modulus of A. That is wrong, students, okay. It's also denoted as det of A, okay. And the value is what, students, is nothing but top to bottom A, D, you multiply top to bottom, subtract with bottom to top, C and D. So AD minus CD, okay. AD minus, sorry, BC, this one, BC students, okay. Clear? That's it. It is only and only valid for square matrix, okay. Now, so we'll be going in much, so what is a detailed one, but not too detailed also, okay, because it is for the KCT crash, so we'll be seeing in a faster manner. Now, determinant for an order one. So very simple, nothing is there. What is a square matrix is there, order one, 1 cross 1, okay. So what is the determinant value? Directly that value only, correct? Nothing more than that. Now order 2, what do you have to do? A is equal to A11, A12, A21 and A22. So if I want to find the determinant, so det of A will be what? Denoted by det of A is equal to, sometimes triangle also we write. So A11, A12, write it down like this, A21, A22. Now what do you do? Top to bottom, students. Top to bottom, top to bottom. So you multiply top to bottom, then subtract from bottom to top, bottom to top. Okay, A21, A12. Okay, so we can understand like this. A lot of people, you can understand like this. This is our main diagonal. Okay, this is my principal diagonal or like main diagonal. Okay, and this is my off diagonal. Okay, so product of main diagonal elements minus product of off diagonal. Let's see an example. Example is 2, 4 minus 1 and 2. So what we'll do? So 2 into 2. So how much? 4 minus bottom to top, minus 1 into 4. Okay, so 4 plus 4 will get 8 students. Okay, let's see here also. We have x, x plus 1, x minus 1 and x. So first what we will do, we'll multiply these two. So x into x square minus these two. So x minus 1 into x plus 1. So that we will get x square minus 1. So that is equal to x square minus x square plus 1. So that is equal to 1 students. Okay. Now, let's see for a 3 cross 3 or for an ordered 3. Now in case of ordered 3, what happens? The determinant can be expanded along any row. You can expand along this, you can expand along this row 2, you can expand along row 3. Somebody says, sir, if we can do along rows, why can't we do along column? Yes, definitely you can do along column. Column 1, column 2, column 3. Any whichever you want, you can expand. I'm just showing here in this video for R1, row 1. You can do for any. You can check with all 6 also. Any doubts? Put the timestamp, put it on the comment section. Do tell us. In the WhatsApp group is also there in the description below. Okay, and the website is also there. Once you're done writing your short notes, students, please upload your short notes so that consistency is maintained. Okay, now, so expansion along R1. Okay, so how do we expand along R1? Let's see. Very simple. Okay, now, so what do you have to do? So if you are expanding along R1, take the first element. Okay, so what is that? A11. Now before that, we have a sign thing. What is it? Minus 1 power I plus j. So for the first one, okay, what is I plus j? Minus 1 power. My first one is what? First row and first column. So both are one. First row, this is for the first time. This is for the first j. So for the first element A11, you can see I and j are both 1. So minus 1 power, 1 plus 1. Okay, and then leave that row, students, and leave that column. Whatever you get it, there you have to do top to bottom, bottom to this one. So you will get a determinant of that A22, A31, A23 and A32. So multiply top to bottom A22, A33 minus A32, A23. Okay. Now again same way. So first is this one is done. Now we'll take the second element. We are expanding along what? Row 1. So A12 will be what? Minus 1 power. I is 1 and for the second column J is what? 2. So minus 1 plus 2. So it is what? Minus 1 power odd number 3. So it will be what? Minus. So negative sign, students. Okay. Now for this negative sign, I will give you a shortcut also. Nothing is there in this. A21. Again, for this, if you have taken this, so leave that row, leave that column. It's like a cross sign. Leave that row, leave that column. So A21 and this one. So what do you get? A21, A33, A23, A31. Okay, multiply top to bottom, bottom to minus, bottom to top. A33 minus A31, A23. Okay, and then coming to the third one, A13, leave that row, leave that column. Okay, so what are you getting? This part. So A21, A22, A31, A32. Okay, top bottom, just multiply it. Okay, get the determinant value. Okay, A31, A22. Done. So once you're done with this, you'll be able to expand along row 1. Now what about the sign, students? The sign is pretty much simple, students. If I'm starting from here, if you see this one is what? I 1 plus 1. So positive, then alternate, negative, positive, negative, positive, negative, positive, negative, positive. Correct? That's it. Alternate, you can go about it. Okay? Nothing is there in this. Correct? Now, or you can check if the sum of I and j is odd, then it is negative. If the sum of I and j is even, then it is positive. So if I plus j is odd, then the whole value, this will be negative. And if I plus j is even, so positive. Okay, so nothing more than that. So this is the way we expand. Let's see with a real example, how will we expand it. Okay. Now, for the ease of calculation, students, what you have to do, take that row or that column which has more number of zeros. So I could have taken this column, I can take, okay. If I take this, I have to expand, for all three I have to do, okay. And if I take the third column, C3, I just have to do for only for this 4. Okay. So always try to take a row or a column which has more number of zeros. Okay. Clear? And I already told you odd even. If minus 1 power odd is coming, then it is what? Negative. And if minus 1 power even is coming, then it is what, student? Positive. Pretty simple. Okay. Now, so let's see, let's expand it along C3. Why we are expanding along C3, is that clear? 2 zeros are there, student, nothing more than that. So we just have to expand along 4. So leave that row, leave that column, what is there? Minus 1, 3, 4 and 1. Solve it. Minus 1, 3, 4 and 1. Now for 4, what is minus 1 power? What is INJ? So it is first row and which column? Third column. So 1 plus 3 is how much, student? 4. So minus 1 power 4, that is what? Positive. Correct. So positive here. So 4 and then you just expand minus 1 into 1. Minus 3 into 4. So what do you get? What do you say? Plus 4 minus 13. So 13 fours are how much, students? 52. Tables also memorize a bit. Calculations will be a bit faster. Okay. Done. So we expanded so easily and we got the answer. If somebody would have done a long row 1, you would have got the correct answer, but it would have done a lot of work. Okay. We don't want to work that much. We want to work smart. Okay. Now let's see. Same one more example. I have taken 2 minus 1 and minus 2. 0, 2 minus 1, 3 minus 5 and 0. What you can do, pause the video and try it yourself. Okay. Pause the video and try it yourself. Let's see. So we can expand along what? C1 column because 1, 0. We can expand along C3 column because again 1, 0. We can expand along row 3, correct? 1, 0. Or we can expand along row 2, again why? 1, 0. Okay. So whichever makes it easy, we can expand. So let's say I'm expanding along the column 1. Okay. So 2, then leave that row, leave that column. What do you get generating? 2 minus 1 minus 5 and 0. Correct. Then 0 is this, so I don't have to work about anything about the sign. Okay. Done. Plus. Then the last one, again I know this is what? I minus 1 power I plus j. So this is third row. So 3a. And which column? First column. So minus 1 power 4 is how much, students? Positive only. And I can go by plus minus also. So 3 into, leave that row, leave that column. What I'm generating? Minus 1, minus 2, 2 and minus 1. So minus 1 into minus 1 is equal to 1. And here 4. So minus 10 plus 15, students. How much? That is 5 is the answer. Clear? So pause the video, solve it out yourself. You'll be able to understand. If still any doubt, put it on the comment section, put it on the WhatsApp group, or you can upload and put it up in your doubts in the website also. Now, coming to the next section, students. Properties of determinants. So what are the different properties we need so that we can do it fast way? Now, these properties are more important for KCET. Okay. And among these, which one are very more important or very much important? We'll show it. Okay. Now, what you can do, mod of, det of A, student, is equal to what? Det of A transpose. Whether you find the determinant of A or you find the determinant of A transpose, both same thing, students. Okay. No difference in that. Whether you find the determinant of A or determinant of A transpose, no change. Okay. So no change in the value of determinant if we transpose it. Clear? Now. So this one is pretty simple. You can take with an example 1, 2, 3, 4. Find the determinant, you will get minus 2. Okay. You do the transpose 1, 3, 2, 4. And again find the determinant, again minus 2. So pretty simple. Okay. Coming to the second property, change any two rows or columns, student, you will get the sign changed. Okay. So let's say we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. We have one. What we did is we interchanged. What would we interchange? Row 1 with row 3, student. What we did? Row 1 interchanging with row 3. So 1, 2, 3 went down and 7, 8, 9 went up. So what will happen? A negative sign will come up. Okay. If we do one interchange, one negative. If we do two interchange, what will happen? Negative and negative will make what? Positive. In real life, it doesn't happen. So don't do one mistake. After that, you did one more mistake. You'll be ending up in a bigger mistake. Don't do that. Okay. Now let's see, students. Okay. Now, coming to the next property, students. Any two rows or columns are identical. If any two rows and columns you see identical, like let's say 1, 2, 3 and 1, 2, 3. The moment you see something like this, directly put a 0. Now, second thing comes is if they are proportional. You saw, sir, 1, 2, 3 is there, and here it is like 3 times of that. 3, 6 and 9. So what it will be? Directly 0 again. No problem. You can just take what is it, 3 common out and make it as 1, 2, 3. So same thing, students. Okay. So any two rows, either they're identical, understand, or they're proportional. Both way they'll end up in being 0. The determinant value will be what? 0, students. Okay. Clear till here? Now let's see the property number 4. Now, if each element of a row or a column is multiplied by k. Now, this is very important. Okay, among important, it creates a lot of confusion because in determinant we have a different thing. In what you say matrices we have a different thing. Okay, so let's see. So we have a determinant. Let's say a1, b1, c1, a2, b2, c2, and a3, b3, c3. Okay. Now we are multiplying. Let's say the first row with k. So ka1, ka2, kb1, kc1, correct. So what will happen if I want to find the determinant, new determinant value? It will be k times, just k, take it out, the old determinant. Okay. So k times of old determinant. If the same thing would have done in matrix, student, very important, if the same thing would have done in matrix. Okay. Let's say we have a matrix A, what do you say? A, B, C, like A1, B1, C1, A2, B2, C2, and A3, B3, C3. Okay, and would have done k times of A. Then in case of matrix, all k will would have been multiplied with all of them, K1, KB1, KC1, okay, KA2, KB2, KC2, okay. So that is important here, KA3, KB3, KC3. So we'll come up with this formula also. In that case, what we have to do, I'll show you. Okay. So till here, any doubts, do put it in the comment section, student. Let's see the next part. Now let's see the property 4 of the determinant, student. Okay. If we have any row or column which is written as a sum of 2 or more terms, what we can do, we can split it up. What we can do? We can split it up. Let's say the first row is the elements in the first row, they're written as a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. So what we can do, we can split them up and make them into two determinants. And the first one I've just taken a1, a2, a3, and the second one I've taken lambda 1, lambda 2, lambda 3. So I can do it like this also. Okay. So let's see example. What is the usefulness of this property? Let's see. So they have given a question A, B, C, A plus 2x, B plus 2y, and C plus 2z. And the down is x, y, and z. So what you can see is the second row, student, okay, is written as a term of what? Two terms, okay. Now, so the second row we can split it up. So we can split them up into two determinants with the help of the second row. So one I have taken A, B, and C, and the other I have taken 2x, 2y, and 2z. So we got the first determinant A, B, C, and x, y, z. Okay. So if you can see, the row 1 and row 2 are same. So the value of the determinant is what? 0, student. Correct. If any two rows or columns are identical, then the value of the determinant is what? 0. So that's why 0 here. Now if you see the second one, A, B, C, and we have taken these elements 2x, 2y, and 2z, 2x, 2y, and 2z, and here x, y, z, student. Okay. So what do you see? These two are proportional, students, double of each other. So again, we know the term, so 0. So the total value is 0. See, we don't have to solve the equation, solve the determinant. Okay. So if you understand and do it, it is very simple. Coming to the next property, property 6, very important again. Okay. Now, if what we are doing is we have a determinant delta, let's say, which is equal to a1, a2, a3, b1, b2, b3, and c1, c2, c3. Okay. This determinant we have. Now what we have done is we have done R1 row 1 is equal to row 1 plus k times of row 3. So when we are doing this is what we are doing here is to some other row we have multiplied some zero constant value k here. Okay, and then we added to some other row. Okay, so in this case we have taken row 1 and we have multiplied k into row 3 and then we have added with row 1. So in that case scenario, what happens is the row 1 changes, so it becomes a1 plus kc1, a2 plus kc2, and a3 plus kc3. Okay. So now if you see, the value of the determinant remains same only. Delta and delta 1 is same. How? It says, sir, we have multiplied this k with the third row and then we have added to the first row. How does it remain same? Let's break it up. The property 5th will apply here and we'll check it out. So what we have done, this first two elements we have broken up and written in form of two determinant. And if you see here, KC1, KC2 and KC3 and the third row C1, C2 and C3, they're proportional to each other. The value of this determinant is what? 0. So the actual value of the determinant remains what? This one only. Clear? So not going too in depth in the property, students, just on the top what you need to know for the KCT solving. Okay? Any doubt, put it on the comment section. Now, so same thing we have written here in the mathematical form. If you have you applying this law that R of I, rho of I is equal to R of I, we are doing what you say R of I plus K times of R of J. Then the determinant what we are forming is same thing. Now if property 4, if you are multiplying K to some row element 1, then what happens? The value of the determinant becomes K times of that. Okay, clear? Now there is a difference in multiplication to a matrix, okay, scalar multiplication to a matrix and scalar multiplication to a determinant. Okay, so both these two things are different. Okay, so we'll show you. Okay, don't worry. Now here this is the most important property which we were talking about. So determinant of Ka, okay, that is equal to K times of n into determinant of A. Now you will say, sir, it was different for matrices and different for determinants, so understand. Okay, so there is a simple difference. So when I say that determinant of K, so determinant of means determinant of this value means what? K times of matrix A. So the moment we write that K times of matrix A, it means what, student? That each and every, it means matrix multiplication with a scalar. Each and every element, okay, is multiplied, okay, of A is multiplied by what? K, correct? Multiplied by K. So what will happen? This K inside means what? Each and every one is becomes AK, BK, CK, DK, EK, FK and GK and GK, HK and IK, correct? So that is equal to, in the case of determinant, if I'm finding the determinant of this, from row 1 K will come out, from row 2 the another K will come out, and from row 3 another K, making it total for a third order K power 3 into data of A. Clear, student? So that's why the property comes here like this. Okay, this one. Clear? Now, very important property, students. Okay, coming to the next property. If you have a diagonal matrix, the moment you have a diagonal matrix like this, 1, 5, 7, and they want you to find the determinant, just multiply the diagonal elements, nothing more than that. Now this same thing is valid for triangular matrix also. Okay, like 1, 2, 3, maybe upper triangular, maybe lower triangular, doesn't matter, 0, 0, 0. Just multiply 1 into 2 into 3. Clear? No doubts. Let's come to the next part. A and B are two square matrices of same order. So mod of AB is same as okay. A and B are square matrix of same order. So then determinant of AB is equal to what? Determinant of A into determinant of B. Simple as it is. Okay. Next property, if A power n is there and then determinant is there, you can first find the determinant and then do the power. Okay. Now again, this is also a very good property. If by putting x equal to alpha, you are able to make the whole determinant 0, then x minus alpha is a factor. Clear? Very simple property. Let's say we have x, what do you say, 1, 2, and what do you say, let's say what we have here is again 2. Okay, so if by putting x equal to 1, I'm able to make 1, 1 and what do you say, same thing, and they're getting the whole value of the determinant becomes what do you say, 0. So x minus 1 is a factor. Clear? Now, let's see the next property. This property is again very important for KCET students. Okay, so understand, if determinant value will be equal to 0 if it is a singular matrix, then it is a singular matrix, then determinant value is 0. If non-singular, determinant det A is not equal to 0. Okay, so we know that. Okay, so and if it is non-singular, inverse is possible. If it is singular, inverse is not possible. Why? We'll see the reason. Okay, now next, again, this is very important for your KCET part. Okay, that determinant of a skew symmetric matrices, it is equal to 0 if the order you have is of odd, like let's say 1, 3, 5, and it is a perfect square if it is an even order like 2, 4, 6. Okay, clear? Now determinant of A inverse, student, is nothing but 1 by determinant of what do you say? 1 by determinant of A, and that is equal to determinant of A whole inverse. Okay, clear? Now, where A is non-singular means inverse is possible. Okay. If AB is equal to 0, it means that determinant of A and determinant of B both equal to 0. Coming to the next property, area of triangle. Now properties are done. Area of triangle, very simple. They have given you 3 vertices of a triangle. Let's say the first vertex is x1, y1, x2, y2, and x3, y3. So area can be find it out by determinant method. This is determinant method. Area is equal to half of, write down the vertices x1, y1, x2, y2, x3, y3, and then write down 1, 1, 1. Solve it, you'll get. Now since we know area is always positive, so we use absolute value. Now if sometime the area is given to you, a lot of students they skip this plus minus. Okay, so if area is given to you as 3, always used in order to solve plus 3 also and minus 3. Otherwise you'll get one less solution and you will be wrong in the exam. Okay, so try not to do this mistake. Okay, let's say I've taken a question to explain the same thing. Find the value of k if the area is given as 3 and the vertices are given. So I'll just put the matrix method half of 1 3 0 0 k 0 1 1 1, and that is equal to plus minus 3. Okay, so minus 3, I'm expanding along this one. Okay, so minus 3 into 0 into 1 minus k into 1. Okay, that is equal to plus minus 6. So solve it is equal to 3. Can I send this 2 to this side? That's a 6 is equal to plus minus 6. So k is equal to what? Divided plus minus 2. Done. So if area of 3 points is given as 0, it means what? It is a line. All 3 points, line is a line. So in that case, what will happen? The area will be what? 0, students. So these are collinear points. Okay, lying on a straight line. Coming to the next section, the minor. What do you mean by minor? Minor is pretty simple again. Don't get too much confused. Basically, if let's say I want to find the minor of the first element, so I'll leave that row, leave that column, whatever the determinant I'm generating, that is my minor. Correct? Again explaining. Minor of any element is what? Leave that row, leave that column, whatever the determinant you generate, that is the minor of that one. So 5, 6, 8, 9. So that is equal to top to bottom. So 45 minus bottom to top 48. So minus 3. Clear? So minor of an element A of ij is obtained by deleting the ith row, jth column of which A of ij lies. Very simple. Okay. Let's say somebody says, sir, let's say what if I want to find the minor of the last one? So leave that row. So third row, third column, leave it. What is left? 1, 2, 4, 5. Solve it. You'll get the answer. Okay. Clear? Nothing more than that, student. Okay. Now, coming to cofactor, again very simple. Cofactor is nothing but minor with a sign. What is cofactor? Don't get too confused. Minor with a sign. So how do we put up sign? Minus 1 power I plus j, and then with minor of m of ij. So let's say I want to find the minor of first one, 1 1. So minor of 1 1 is I know, leave that row, leave that column. I got 3. So very simple. The cofactor of 1 1 will be what? Minus 1 power I is 1 and j is 1. So plus only. And m11 is equal to what? 3. Clear? Now I'll show for any other also. Let's say last one, m22. So if I leave that one, that is equal to 1. m22 means what? Leave that row, leave that column, I'll get 1. Clear? If I find the cofactor 22, so that is equal to minus 1 power 2 plus 2. Again even number, m of 22. So that is equal to 1. Clear? So cofactor is nothing, student, but minor with a sign. Next is values of a determinant. Okay, how do we obtain? We obtain by sum of the products of elements of a row with the corresponding cofactor. Okay, let's say you have a matrix like this: A11, what do you say? A12, A13, A21, A22, A23, A31, A32, A33. Okay, so the determinant of A is equal to what? Take any element, multiply with its cofactor. A11 also we denote it, or C11 also we write, so both okay. Plus second element with its cofactor. Now here don't do mistake, here don't put a minus sign, okay. Plus third one with its cofactor, because your cofactors already contains a sign, student. Okay, so no need to separate. Sir, while expanding you showed plus for the first one, second one minus, and plus again alternate. Okay, here you didn't put, because this cofactor already contains the sign, student. Okay, so direct done. Now one very important, if you have taken the element of the first but cofactor of second or third, and if you keep doing it till the last one, expand till the last one, you'll end up getting the value of determinant 0. Okay, so elements of a row or column multiplied with cofactor by any other will always end up in 0. Now coming to adjoint. Adjoint, what is adjoint? Adjoint of a matrix is nothing but transpose of cofactor matrix. Take this one. A is equal to what? 2, 3, 1, 4. So first find the cofactor matrix. So C11 is 4, C12 is equal to -1, C21 is equal to -3. Now what do you do? Stop the video, find the cofactor matrix, put it in that, do the transpose. Once you are done with the transpose, you will be able to get the adjoint. Okay? So very simple. Clear? Now, small trick for finding the adjoint, because in exam we won't have time. What you do? Interchange the main diagonal element. Okay? So here interchange it. Okay? Clear? So here you interchange. So it will be A22, A11, and the off diagonal you multiply with a minus sign. So A21 minus A21 minus A12, done. You got the adjoint. Now properties of adjoint, very important. Now I won't be able to explain each and everything in detail here. Okay, when we'll be doing the PU part, we'll be explaining it. Okay, so as of now, just memorize the properties and memorize them like very properly. Make a short note of it. So while solving question, you'll have that short notes and you can refer to it, and it should be like on your fingertips. Okay, so that you can make it fast. So at A into adjoint of A or adjoint of A into A is basically det A into I. Means it is a what? Matrix part. We got it. Det A means whatever value we got into the, what do you say, unit matrix. So one, let's say if it is 3 order, 1 0 0 0 1 0 or 0 0 1. Okay, like that. Now determinant of adjoint of A, student, is nothing but adjoint of determinant of A power n minus 1, where n is what? The order. Third order, second order, depending on whatever the order of the determinant is, will do. Adjoint of transpose of A. So basically it's same thing. You first find the adjoint and then do the transpose. Okay, pretty simple. Adjoint of some value k multiplied with A is equal to just k, take it out. Now here it will be order minus 1. Okay, very important. Order minus 1 into adjoint of A. So let's say if you have an example, adjoint of, what is it, 3A. So what you have to do is equal to 3 power whatever the order. If it is a 3 cross 3 matrix, so then it will be 3 minus 1 into determinant into adjoint of A. Okay, now, so adjoint of A power x. Now we have some power, like let's say A square, A cube, something like that. So that is same thing as adjoint of A. You find the whole and then do the power. Okay, so if I'm finding adjoint of A square, don't get confused, sir. I don't know, sir, how to find the adjoint of A square. It's basically simple. Adjoint of A, you find it out, square it out now. Now adjoint of A, okay, so that is nothing but determinant of A whole power n minus 2, where n is the order, into A. Now determinant of adjoint of A, very important property for the KCD part. Do mug it up, okay? Do remember it, make it on your fingertips, n minus 1 whole square. Determinant of A into n minus 1 the whole square, okay? Very important property for KCT. These all properties are very important. Now coming to this property, again same thing as reversal law. Okay, adjoint of AB is first, we'll write the second one. Adjoint of B, the last one comes first, into adjoint of A. That's it. Now what is inverse? If we have a square matrix and that is invertible only if and only if A is non-singular. So what do you mean by that non-singular? Means the determinant value is not equal to 0. Because we know inverse formula is what, student? Adjoint of A by det A. So if determinant value this becomes 0, then it won't be possible. No, denominator cannot be 0. So not defined it will be. So it has to be non-zero. So if it is non-zero means it means what? That it is non-singular. Now if we have AB is equal to BA is equal to I, so we can say A is inverse of B and B is inverse of A. Pretty simple. Now let's see how to find the inverse of a 2 cross 2 in a very short way. Again, we'll use the property of the adjoint which I taught you just now. So A inverse equal to adjoint of it. We already got interchange the main diagonal one. Okay. And the off diagonal you multiply with minus divided by determinant of it. Done. The properties of inverse always unique, students. See, if I do the reciprocal of 2, it is 1 by 2. It can't be any other number. So same thing here, inverse, if it exists, always unique. If I do double time inverse, A inverse and then inverse it again, you'll get A only. Simple. If you do 2 inverse and then do one more inverse. So 2 inverse is half and then half inverse is what? 2 only, no? So you get back. Now A transpose and then inverse, it's basically as you inverse it and then transpose it, okay? Now AB whole inverse, again reversal law. So B inverse will come first into A inverse. Clear? Now coming to the next, determinant of A inverse is nothing but, what is a determinant of A? Then do inverse. A into A inverse, what happens? It will become A inverse into A, same thing as I. Okay, basically they're trying to say 2 into half will be what, student? Half into 2, that is equal to what? 1 only. Clear? Now, very important property for your KCET part. A lot of times questions have come. Invertible symmetric matrix is there. Invertible means the determinant is not equal to 0. So it exists. So if you do inverse, you'll always get a symmetric. So directly you can put an answer, okay? Now, differentiation of determinant, a very important topic for your KCET. We'll be doing a lot of questions based on this. It's pretty simple. Let's say we have a, matrix A determinant x1, x2, x3, y1, y2, y3, and z1, z2, z3. Now we want to differentiate. So in order, for the case of differentiation, dA by dx, first differentiate the first row. Okay, we start by differentiating with the first row. Do all the differentiation of the first row elements. Okay, and leave the other two row as it is. Okay, differentiation of the first row, leave the other two row as it is, then plus sign. Now differentiate the second row, leave the other two rows as it is. Okay, leave the other two rows as it is. Okay, and dy3 by dx, and then plus again, leave the, now differentiate the third row, leave the other two row as it is. So what we do here, one by one we differentiate each row, leave the other two rows and then add up. Okay, that's it. Okay, nothing more than that here. So differentiation of a determinant means what? Differentiate row wise one by one. Take the first row, take the second row, take the third row, or column wise one by one. You could have taken this first column, you could have taken this second column, or you could have taken this third column one by one, added up. Okay. So differentiation part is clear, students. Coming to the next part. System of linear equations. Okay, very important. System of linear equations. How do we do it? So first, in this understand, in class 9th, we have done what is a consistent solution, what is inconsistent. So it comes up into two parts, consistent, inconsistent. Consistent by word means that you either have unique solution or infinite. So you remember unique solution means what? Intersecting lines, 1 point, or what in 9th we did for 2 lines, we used to do like this. Okay, infinite solution like this, one line overlapping on the other. Inconsistent means what? There is no solution. So parallel lines, they never meet, so no solution. Okay, so just shown for a 2 cross 2. Okay, now let's see the Kramer's rule part. So we have an equation a1x plus b1y is equal to c1, and we have a2x plus b2y is equal to c2. Now we can represent this in the form of ax is equal to b, where a is equal to the matrix formed by the coefficients of what? X and y, a1, a2, b1, b2, and b is the constant matrix formed by the constants. Okay, c1, c2. So now ax is equal to b is non-homogeneous and ax is equal to 0 is homogeneous. We'll see both of them. So for the non-homogeneous ones, directly first we can apply. Okay, what we can apply? We can find d. D is basically equal to a1, b1, a2, b2. Correct. a1, b1, a2, b2. Now, if d1 is not, d is not equal to 0, directly you can say, student, it's a unique solution. And you can find the value of x and y, x equal to d1 by d, y is equal to d2 by d. And this is consistent. Now, and what is your d1? d1 is nothing but remove the first column element with the constants one. So c1, c2, b1, b2. So that is d1. And what is your d2? Remove the second column one with c1, c2. So that is your d2. So if d is equal to 0, then we check if all d1, d1 and d2, all three of them are 0, then we can say infinite solution. If d is 0, but any of D1, D2 is a non-zero, we can say no solution or inconsistent. Okay. Again, recapping it, if we know that D is not equal to 0, directly we can say it is unique solution and we can find the value of X and Y. If D equal to 0, then two case stands. One case, all three of them is 0. D, D1, D2 is 0. In that case, it is infinite. And if D is equal to 0, but any one of them, D1 or D2 is a non-zero, okay, then it means no solution. This can be extended for three variables also. Clear? Now coming to the next part, student. Case 2, if we want to solve it by matrix method, Ax is equal to B. So X is equal to what? A inverse B. So here we find the matrix, okay. Here we find the inverse, A inverse, and depending on that we do it. So if A is singular means, what does it mean? That inverse doesn't exist. That A is equal to 0, inverse doesn't exist. So now what will happen? No solution, and then in that case we can't do anything. And if A is not equal to 0, then it will have unique solution. Now if A is singular, okay, in that case we have two options. If adjoint of A into B is not equal to 0, then we can say it has directly no solutions, inconsistent. But if adjoint of A into B is equal to 0, okay, that is 0 is here, 0 matrix, then it may be or may not be, consistent. It can be infinite, it can be, no solution also. So keep, keep that in mind, very important. Okay. Coming to the last part, where homogeneous. So once we start solving questions, you'll be able to understand more in depth. Homogeneous will be like, Ax equal to 0 form. Okay. Like 2x plus 3y is equal to 0 and 7x plus 9y is equal to 0. In this kind of situation, first thing is, if determinant of A is not equal to 0, then we have trivial solution, all values 0, 0, 0. And if determinant is equal to 0, then we have infinite solutions. Okay, means whatever values of x and y doesn't matter, they will all satisfy it. Okay, that's all for the determinant formula plus concept video. Now we'll be giving you the PYQ plus the exemplar questions in a very short time. So make short notes fast. By night we'll upload the PYQ and the exemplar. So work hard, give your 100%.